Hi guys, this is your math master for today, and we are going to discuss the properties of operations on the set of integers. This is based on the Mathematics 7 Self-Learning Module or SLM on properties of operations on the set of integers. Now you can see on the screen the 6 properties of operations that we're going to discuss. Number 1 is the closure property. Number 2, commutative property. 3, associative property. The 4th is the identity property. The 5th is the inverse property. And the 6th is the distributive property. We're going to discuss this one by one, and I'm going to help you understand it easily, and I'm going to help you and give you some ideas on how to remember them easily also. Okay, so number 1 is the closure property. The closure property is being used for addition and multiplication of real numbers or integers. For example, here you can see here on the screen a plus b. So a is a real number and b is another real number, and it will give you another real number, for example c. Okay, so for example, let's get an example here. For example, a is equals to 1 and then b is equals to 2. Therefore it will give you another real number or integer, which is number 3, of course. This is an example of closure property. 1 and 2, when you add them together, when they are close together, from the root word closed, from the word closure, they become 3. Okay, so you can also make an example here, like for example, 1 apple plus 2 apples is equals to 3 apples. So if you have 1 apple and then somebody gives you 2 more apples, therefore it will be another number of apples. So you will get 3 apples. Okay, when you combine or make close together one integer or one number, one real number, and another real number when you add up together. Now, with regards to multiplication, let's say a times b, or a multiplied with b, it will give you another real number. For example, it's c. Okay, now let's make a number representation. For example, a is equals to 3 and then b, okay, the dot there is a multiplication sign, so it could be times or x times, for example, b is equals to 4. Therefore it will give you an answer of another real number, which is equals to 12, right? So 3 times 4 is equals to 12. Okay, so when you have 3 apples and then you want to multiply that into 4, okay, you will put 3 apples to 4 baskets, and 3 apples on each basket. It will give you a total of 12 apples altogether, right? So the apples and the baskets, you close them together, you join them together, then 3 times 4, it will give you 12. Now, how could we remember the closure property? Okay, I told you already that in the closure property, the word closure is, we could get the keyword here, the word closed. Closed, which is not open. Close, or you are close together. For example, your mom and your dad are close to each other. Therefore, when your mom and your dad is together, they will produce a baby, which is another person. Okay, your mom and your dad will make another person or baby. All right, so mom and dad, mom plus dad is equals to a baby. Okay, another number, another person. And then for multiplication, when your mom and your dad also multiply together, it will give you another person, another baby, right? So So just base the word closed in the closure property. So when two numbers are close to each other, it will produce another real number, right? A plus B equals another number, real number, another unique real number, and multiplication also. A times B, it will produce you a C, which is another real number. Okay, so closure property, remember the keyword closed. When you are close together, you will produce another number. Okay, let's go to number 2, commutative property. Okay, with regards to addition, you could see on the screen A plus B is equals to B plus A. Okay, so it's just the order. You just change the order of the numbers being added. So for example, A is equals to 1 plus B, which is equals to 2. It's just also the same as 2 plus 1. Okay, 2 plus 1. So 1 plus 2 is just equals to 3. You can see here that this is 3. And then 2 plus 1 is also equals to 3. So whatever is the arrangement of the numbers being added, it will just give you the same total or sum for the two numbers. Okay, that is what we call commutative property in addition. Now for the multiplication part, it's also like this, like A times B is equals to B times A. For example, 2 times 3 is just equals to 3 times 2, right? So for example, 2 times 3, that will give you a 6, right? And then 3 times 2, that will also give you a 6. So whatever is the order of the numbers in the multiplication operation between two numbers, like for example 2 and 3, it will still give you the same product or the same answer, right? Okay, so how do we remember the commutative property? Commutative property, okay, I will give you the keyword here, commute. Okay, from the word commutative property, we could get the word commute, right? All right, okay, commute, or we could make a change here. For example, we could change swap. You commute and you swap to each other. For example, here the addition, you swap A and B, right? A plus B, and then you swap the order. Okay, let me be in the first part. So B plus A, it will just give you the same number. For example, you and your friend, you are seated together. Okay, you are seated on the first seat and your friend on the second seat, and you want to swap together, right? So your friend will sit on the first chair, and then you will be sitting on the second chair. Therefore, you are still the same two persons, right? You and still your friend. It will not give you 3 persons even though you swap the chairs. Okay, so that's just it. So when the two numbers are swapped in addition, A plus B, when you swap together, it becomes B plus A. It will just give you the same answer. Also in multiplication, A times B, when you swap them, B times A, it will also give you the same answer. Okay, commute, swap, or exchange position or order of the numbers. That is commutative property. Remember closure property. If you are close together, it will produce another number, another real number. Now commutative property, if you swap, exchange, or commute to the other place, it will give you another. It will give you the same answer in addition or in multiplication. Okay, now for the associative property, okay, the key word here is associate. Associate or make in a group. Okay, you form a group, combine together. Okay, so for example here, addition, A plus B closed in parenthesis or bracket plus C is just equals to A plus b plus c close into parenthesis or bracket. Okay, let's give an example here. A plus b, for example, this is 1 plus 2. Oops. 1 plus 2, then plus 3. It will give you an answer the same as 1 plus 2 and 3 combined together. Okay, you can still see that. You can see that 1 plus 2 here is just equals to 3. And when you add it to 3, it will just give you an answer 6 here. And also here, 2 plus 3, it will give you a 5. And when you add it to 1, it will give you a 6. Right? So that is the addition associative property with regards to addition. Now what about in multiplication? It's just A times B here. A times B, for example, 1 times 2. Okay, times 3. It's just equals to 1 times 2 multiplied times with 3. Right? So 1 times 2, it will give you a 2. And then when you multiply it with 3, it will give you a 6 here. And also 1 times 2, 1 multiplied with 2 times 3 is equals to 6. And then 1 times 6 is equals to 6. It's just the same answer. Now, how could we remember the associative property? It is the groupings. The change of the group. You see here in addition, the first is A and B are grouped together. And on the second part, B and C are grouped together. But still the same answer. Right? Whatever, even if you change the groupings of the order of the groupings in addition, even in multiplication, it will give you the same answer. Okay? So, for example, one example here is in the classroom. If you are 30 students in the classroom, even though you group with your friends, and there are also other groups inside the classroom, but still when you add all of the groups inside the classroom, it still equals to 30, right? Even though you change the group, you go to another group, and then the other groups will also make another group, but still when you add all of the members of each groups, right, it will give you the same total number, which is 30, because you are all 30 students in one classroom. So that's a practical explanation of associative property on how you group together. Same like with the multiplication. Okay, so however you group it, when you change the group in multiplication, or you change the group in the addition of numbers, of real numbers, it will still give you the same answer. Okay, now let's go to the identity property. Identity property is, for example, in addition, A plus 0 is equals to 0 plus A, which is equals to A. Therefore, when you add 0 to A, it will give you the same number. Okay? So, any real number, when you add 0 to it, it will give you the same number. Okay, one example here, for example, okay, let's say 9. 9 plus 0 is equals to 9, which is also equals to 0 plus 9. It's just equals to 9, right? 9 is equals to 9. Same with the multiplication here. When, let's for example, A is equals to 8. 8 multiplied with 1, it will just give you the same answer when you multiply 1 multiplied with 8. So the multiplication, in the multiplication, when you multiply it with 1, it will give you the same answer when you reverse the order. Okay? If you multiply it with 1, the number. In addition, when you add 0 to it, it will give you the same number. Okay? That's identity property. Now, how do we remember identity property? Okay, just from the word identity. Your identity is the same. You are still the same, right? For example, apple, one apple, and then you add no apple. Still the same apple, right? One apple plus zero apples, still the same one apple, still the same, right? And for example, one apple multiplied by one, it's still the same apple, still one apple, right? So the identity of the number remains the same. It is the same number. The answer will be the same number as itself. So identity based from the word identity. Okay. Now let's go to the inverse property. Inverse property. Okay, you see the inverse here. Kumbaga baliktad. Okay, inverse or baliktad. Now you can see here in addition, a plus the baliktad or the inverse of a is negative a. It will give you a 0. Same with negative a, and the inverse or baliktad ng a is positive a. It will also give you the same answer, 0. Okay, so when you add the inverse of the given number, okay, additive inverse, for example, a plus the additive inverse of a, it will give you a 0. Okay, I will give you an example here. For example, 7 plus the additive inverse of 7, which is equals to negative 7, it will give you a 0. Same with negative 7 plus the additive inverse of negative 7 is equals to positive 7. It will also give you a 0. Same answer. It will give you a 0 when you add the additive inverse of a given number. Same with the multiplication. So we also have the multiplicative inverse or the reciprocal of a given number. You see here, a times or multiplied by 1 over a is just equals to 1, or 1 over a multiplied by a is just equals to 1, given that a is not equals to 0, because if a is equals to 0, it will become undefined. Okay, so here I'll give you another example here. For example, 3 multiplied by its multiplicative inverse. The multiplicative inverse of 3 is its reciprocal or its inverse is 1 over 3. When you multiply 3 times 1 over 3, it will give you a answer 1. Now, what about 1 over 3? When you multiply it with its multiplicative inverse a, or not a, 3, it will give you the same answer, 1. That is the inverse property. Okay, so the inverse, how do we remember the inverse property? The baliktad. As long as the number that's being added to it is the opposite of it, opposite in nature. So let's, for example, 4, and then you add the opposite of it is negative 4. So that's the inverse. But when you multiply 4 with its multiplicative inverse, or the baliktad of it is 1 over 4. So you will give you a 1 here. For the additive inverse, it will give you a 0. Okay, that is the inverse property. Okay, based on the word inverse or baliktad or opposite. Okay, now let's go to the last, distributive property. Okay, the distributive property is you just distribute a certain number to numbers, to addition of numbers or subtraction of numbers. Okay, so distribute from the word distribute. Okay, I'm writing on the screen, it's not so clear. Okay, but you can read that. Distribute. Okay, here from the left, a multiplied by the one in the bracket, b plus c, is just equals to ab plus ac. Or if it's in the right, a plus b inside the bracket multiplied with c will give you an ac plus bc. Why? Why? Because a times B is just AB, right? Plus, okay, plus here, there's a plus here too, and then A times C, it will give you an AC. Okay, just the same with the one here, C multiplied with A, it will give you an AC, and then also C multiplied to B, it will give you a BC. So there's a plus in between because it's plus. The operation being used is plus, but if the operation being used is minus or subtraction, you can use minus. Okay, that is the distributive property. So you distribute a factor. Okay, they call it a factor. The factor like for here, for example, here the factor is A. You distribute the factor A to B and C, and in the second example you distribute the factor C to B and C. Now it will give you these numbers. Okay, I'll give you an example here. For example, here this is 2 multiplied with 1 plus 3. It will give you 2 times 1 is equals to 2 plus 2 times 3. It will give you a 6, right? Therefore, it will give you an answer of 2 plus 6 is equals to 8. Just the same with if we inverse the from left to right, so that will become like for example 1 plus 3 here multiplied by 2, that will give you 2 times 1 is 2, and then 2 times 3 is equals to 6, which also give you an 8. Okay, that is the distributive property. So you distribute the numbers, the factor to the numbers inside the parentheses. Okay, let's review. Closure property, always remember, when two numbers are close to each other, it will produce another real number. Okay, whether addition or multiplication. Commutative property, when you commute or you swap or you exchange the numbers, the order of numbers, A plus B, you exchange it to B plus A, and then A times B, you exchange it to B times A, it will give you the same answer. Associative property is the order of the grouping of the numbers. So, addition, A plus B first, you group together, and then you add to C, it will just give you the same answer when you group first B plus C, and then you add to A. Also with multiplication, you group A times B first, and then you multiply the answer to C. It will give you the same answer if you group B times C first. You get the answer, and then you multiply to A, it will give you the same answer. Okay, that is associative property. While the identity property, the identity remains the same. A add by 0, it will give you the same number A. 0 you add to A, it just give you the same A. A you multiplied with 1, it will give you the same answer A. Also with 1 multiplied with A, it's just equals to A. So the identity of the number remains the same. Just like 2 plus 0 or 0 plus 2 is just equals to 2. Or 2 times 1 is just equals to 1 times 2. Okay? And it will just give you an answer 2. The identity remains the same. Okay? Now, let's go to the inverse property. The inverse property of in the inverse property is the baliktad. Okay, so when you add a number to its inverse, additive inverse, positive, for a positive number, its additive inverse is the negative number, while for the negative number, it's the additive inverse is the positive of it. So it will give you a 0. Answer is 0. When you add a number to its additive inverse, the answer is 0. When you multiply a number with its multiplicative inverse or the reciprocal, it will give you an answer 1. That is the inverse property. So remember, the inverse property, baliktad, opposite of the given number. Okay. In addition, it's the negative plus positive, it becomes a negative, and negative becomes the positive. Okay, for the distributive property, so you just distribute a factor to to the numbers within the bracket or parentheses. Okay? Distributive from the word you distribute. Inverse from the word baliktad. Identity, the identity property, identity remains the same. The answer is the same. The same given number. Associative property, you change the grouping of the numbers when you add or you multiply the numbers. Commutative property, when you swap the order of the numbers, when you just exchange the order, it's just, the answer is just the same. Closure property, when two numbers are close to each other, they will produce another special real number. Okay? Okay, let's go now to our module. Let's go. Next. Wait. Okay, here. Number 1. Which operation below does not change the value of a non-zero number? Okay, what do you think is the answer? Which operation below does not change the value of any non-zero number? It does not change the value. Remember the identity property. The number does not change. So in the identity property, the answer never change. So it's adding by 1. 1 plus 1 for letter A. Adding by 1, like for example, 2 plus 1 is equals to 3. No, it changed the number, the value. Dividing by 0, 2 plus divided by 0, it becomes undefined. Error in the calculator. What about D? Multiplying by 0. So 2 times 0 is just give you a 0, which is not the same value. But for letter C, multiplying by 1, 2 times 1, it will give you a 2. So this is the answer. It's letter C. Letter C is the answer for number 1. Okay, now let's go to number 2. Which of the following properties states that changing the order of two numbers that are either being added or multiplied does not change the value? Changing the order of two numbers. Remember, when you change the order of two numbers, when you commute, when you swap, when you exchange the order, that is the commutative property. Okay, why? Because, for example, let's say when you add or multiply, when you add 2 plus 1, it will just give you the same answer as 1 plus 2. When you change the order, it does not change the value when added or multiplied. Same with here, 2 times 1, it will just give you the same answer as 1 times 2. Right? Okay, so the answer is the commutative property. Number 3. Okay, let's go to number 3. Which of the following properties states that the two integers that are added and multiplied remain as integers? Two integers that are added and multiplied remain as integers. The set of integers is closed under addition and multiplication. Okay, when two numbers are being added, it still remain. The answer is still an integer. Okay, for example, 2 plus 3, it will give you a 5. Okay, 2 is an integer plus 3 is another integer, is equals to 5. Or let's say when you multiply it, for example, 2 times 3, it will give you another number which is equals to 6. Okay, so real number plus real number is equals to another real number. And 2 multiplied with another real number will give you a real number which is equals to 6. Okay, this is the closure property. This is the closure property. When they are closed, they produce another real number. Remember, from the root word closed. Number 4. Okay, number 4. When two numbers have been added or subtracted and then multiplied by a factor, the result will be the same when each number is multiplied by the factor and the products are then added and subtracted. Okay. Okay, this is what we call distributive property. When two numbers have been added, okay, for example, 2 plus 3 and multiplied by a factor. For example, 4 is just equals to the result when each number is multiplied by the factor, like 4 times 2, you distribute, and then plus 4 times 3. It will give you the same answer, right? This is 5 times 4, that is 20. And then 4 times 2 is 8, plus 12, that is also 20. See? So this is what we call the distributive property. Okay? Now, number 5. Which of the following property states that the sum of the number of any number and 0 is the given number? Okay, 2 plus a number plus 0 is just equals to 0 plus 2. 0 plus 2, let's erase this one. 0 plus 2 is just the same number, 2. Okay, this is the identity property. The identity of number 2 remains the same. The answer is still number 2. Okay? Okay, let's go now. Let's go to the next page. Next page, please. Number 6. Okay, number 6. Which of the following property is used in the expression 2 times 3 minus 5 is equals to 2 times 3 minus 2 times 5? Okay, what property is this? Distributive property, because it distributes the number. 2 distribute to 3, and then 2 distribute to 5, so that's 2 times 3, and then 2 times 5, so that's distributive property. Which of the following, number 7, does not illustrate inverse property? So it's not inverse property. Let's go to letter A. 5 plus 8 is equals to 8 plus 5. This is not inverse property. This is commutative property. They swap, exchange position. 5 plus 8 exchange 8 plus 5. Okay, I think the answer is letter A, because it's not inverse property. Let's check. How about B? 1/2 times 2 is equals to 1. Yes, this is the multiplicative inverse property. 1/2 or 2 multiplied with its multiplicative inverse, which is 1/2, is equals to 1. Also, letter C is additive inverse property or addition inverse property, which is -9 plus its additive inverse, which is +9, is equals to 0. And also dx plus its its additive inverse, -x, is equals to 0. So B, C, and D are inverse. They use the inverse property of operations. Therefore, the answer is letter A, because letter A is commutative property. Number 8. Which of the following does not illustrate distributive property? Letter A. You can see here letter A. A and B is distributed. A is distributed to B. AB, and then A is distributed to C. That's why it's minus AC or negative AC. Then B, 4 times X, distributive also. And then 4 times 3, it becomes 12. That's distributive property. Letter C, 3 times 5. And, letter C is the answer, right? Letter C, tama. Why? Because letter C is associative property. They change the groupings in the multiplication of numbers. Okay, associative is the change of group. Associative property, whatever you change the group of, whether in multiplication or addition. And letter D, it's distributive. 2 times 7 is 14, and then 2 times 5, -5 is -10. Okay, so it's letter C for number 8, which does not illustrate distributive property, because letter C is associative property. Number 9. Which property of multiplication is shown in 6 plus 3 and then multiplied with 4? So this is 4 is being distributed to 6 and 4 is being distributed to 3. So 4 times 6 plus 3 times 4 is equals to the same number. So that is distributive property. Which property? It's distributive property. Letter C. Okay. Number 10. Which of the following property is used in the expression 4, 1 plus 7 is equal to 4 plus 28? That is also distributive property because 4, you distribute 4 to 1. 4 times 1 is equal to 4 and 4 times 7 is equal to 28. So this is still distributive property. Okay? Okay. Now let's go to number 11. Which property of addition is used in 4 plus 7 plus 3, which is equal to 4 plus 7 plus 3 in the parentheses? Okay, you could see here that the ones being grouped here is 4 and 7, and the other part, the one being grouped is 7 and 3. Therefore, it is associative property. You see the changing in the groupings will still give you the same answer. Associative property. Number 12, which is an example of identity property of addition? Remember, identity property, it will give you the same number. Same number. So which one? C? It is number? Letter C. Okay, it's letter C. Why? Because 3, the original number, when you add 0, it still remain the number 3. That is the identity property of addition. Number 13, which of the following does not show the commutative property? Okay, remember commutative property from the word commute, swap, or exchange the order of the numbers. So a plus 8 is equal to 8 plus a. That is commutative property. What are we looking for? Does not show. Does not show the commutative property. So a is commutative property. Letter B, x times y is equal to y times x. That is commutative property also in multiplication. Letter C, m plus n is equal to n plus m. That is also commutative property. While D is 3x times 4 is equal to 12x. Oh, this is what we call closure property. When you multiply two numbers, it will give you a different real number. Okay, so 3x times 4 does not show the commutative property. Therefore, it is the answer. Letter D is the answer. Okay, I hope you have followed me. Very good. Okay, let's go to the next problem, next page. Okay. Okay, number 14. Which property of addition does 5 plus 0 is equal to 5 illustrate? Okay, 5 plus 0, 5. And then when you add 0, it remains 5. So the identity of 5 remains the same. So that is the identity property. Very good. What property of integers justify 12 plus 3 is equal to 3 plus 12? You see, 12 and 3, 3 and 12. Okay, so they just exchange position. Order of the numbers. So it's swap. They swap together or they commute to the other place. So that is the commutative property. Very good. You got it? Good job. Okay, let's go to the next page. Okay. What's in? Properties of operations, the set of integers. Okay, perform the indicated operations. Apply the rules of the operations on integers. Okay, we're going to apply rules for properties of operations. Okay, let's say 12 plus 15. We can use the what? We can use the closure property, which is the answer is 12 plus 15. It will give you a 27. Right? 27. Or you can also use the commutative property. Okay, the order of operations they exchange. 12, 15 plus 12. Okay, good. Now here, also for number 2, you can also exchange the position here. It can also be equals to negative 13 minus 21. It's still the commutative property. We can still use commutative property. Actually, for 1, 2, 3, yes, you can still use closure property also. But I'm just using the commutative property. For number 3, I will also use the commutative property. So negative 7 and then plus 14. Right? Okay. So if you're going to solve this one, this is just equals to what? 15 plus 12 is just equals to 27. Maybe your teacher will ask for the answer. Negative 13 minus 21, that will give you a negative 34. And then the answer here, negative 7 plus 14 is just equals to 7. Okay, so here you can also here do negative 16 plus 9. You can also do the commutative property. 9 minus 16 is just equals to negative 7. Negative 7. Okay, how about 26 minus 13? I can do here distributive property. Okay, I can do 13 multiplied by 2 minus 1. You see, because 13 times 2 is 26, and then 13 times negative 1 is negative 13. And it will give you an answer. 2 minus 1 is 1. Answer is 13. We use the distributive property here. What about this one? Negative 25 minus negative 11. How do you do this one? So this is negative 25 you just combine the 2 plus 11. So this is the closure property. It's just the closure property. Negative 25 plus 11 is just equals to what? Negative 14. Okay, now what about this one? Negative 36 minus 20 is just the same closure. We just combine the numbers. 36 plus 20. Closure property. Oops, sorry. Just equals to 56. Okay, and then for here, number 8, we can do also commutative here. Commutative property, we just exchange the position. This is just 5 times 13. It will give you an answer. 5 times 13, that is a 15. Carry 1, that is 65. Right? Okay, 65. Okay, now here negative 8 minus 6 is just also a commutative property. You can just exchange the order. Minus 6 or negative 6 multiplied with negative 8 is just equals to positive 48. Positive 48. Now here also 12 and then negative 7. Oh, we can still do the same. Negative 7 and then 12 is just equals to negative 84. Okay, 7 times 4 is 14. Negative, carry 1. That's 7 plus 1, that's 8. Okay, negative 9 and 8. Okay, we can still do the commutative property. 8, just exchange the position, and then negative 9 is just equals to negative 72. Okay, now 10 divided by 2. So We just do this one. This is just closure. Oh, but this one is division. Mm-hmm. We can do the distributive property here 2, and then here 5, and then divided by 1. Can do like that. 5 divided by 1 is 5 times 2, that's 10, equals, no, we can't do that one. Sorry. We can't do that one. We can't just do the commutative distributive property in addition and multiplication. So 10 divided by 2 is just equals to 5, right? It's just equals to 5. Because the order of operations, the properties of operations for the set of integers is just applicable for plus and minus, right? Addition and multiplication only. So negative 18 divided by negative 3 is just positive 6. Just positive 6. Okay, we can use the properties of operations for this. Negative 42 divided by 7 is just 6. Negative 6. And then negative 144 divided by 12. 144 divided by 12 is 12. That is a negative 12. Okay. So for the number 12, 13, and 14, and 15, okay, this is a trick. Apply the rules of operations on integers. So we cannot use the properties of operations for addition and multiplication. That's the way we understand. What we can just do is just to divide them. Okay? Okay. Now let's go to the next page. Next page. Okay, fill in the blanks with the exact order, correct, fill the blanks with the correct number that will make it exact. Okay, here 8 plus a number plus another number is equals to a number plus 5 plus 1. Okay, remember the associative property, when you just change the groupings of numbers being added, it's just give you the same number. So if there is 5 plus 1 here, therefore this is 1 here, and this is also 5 here, right? And if this is 8 here, this will put 8 here, right? So what are the numbers? The numbers are 5, 1, and 8. What property is illustrated? It is the associative property. Okay, I'm trying to write it down. Associative property. Okay, the associative property. Now, we will study here below. Okay, now the module as explained now, we'll try to explain the properties of operations for the set of integers, which I already explained to you. So let's read it. So the closure property is when two integers that are added and multiplied remain as integers. The set of integers is closed under addition and multiplication only. So the closure property of addition for real numbers states that if A and B are real numbers, then A plus B is a unique real number. Adding two real numbers produces another real number. Like for example, 15 plus 16, it's equals to 21. Okay, I have already explained this one to you before. Okay, another example, very simple example is 2. A real number plus another real number 3 will just give you another real number, which is equals to 5. Okay, that's just closure property for addition. For the multiplication is on the next page. Okay, next page. For the closure property in multiplication, we multiply a real number A multiplied by another real number B. It will give you a unique real number. A and B are real numbers, and then A times B is a unique real number. Okay, we have an example here below. 26 times 12 is will give you 2, 1. Okay, this is 312. Okay, it's not clear in the module. That is 312. Another example here. Okay, make a simple example. 3 times 4, it will give you a 12. 3, a real number. 4, another real number. It will give you an answer of 12, which is another unique real number. Okay. Now, for the commutative property number 2, changing the order of two numbers. So you see here, A and B, you swap the two, B plus A. Just the same answer. A times B, you swap B times A. Okay. Just the same examples here below. You can see here. Okay. It will just give you the same answer when you swap the order of the numbers, whether it's addition, like for example 1, 2, 3. Well, for multiplication, when you swap the two numbers and then you multiply, it will just give you the same answer. Okay, like 1 plus 2 is just equals to 2 plus 1, and also 3 times 2, it will also give you the same answer with 2 times 3. Now, subtraction and division are not commutative. Okay, for the associative property, changing the grouping of numbers so that either being added or multiplied does not change its value. Okay, for example here, A times B and then you multiply it to C. When you group A and B, it's just equals to A and you multiply it to B and C when they're grouped together, the B and C, right? You can see the example here, number 1. See, 2 times 3, it will give you a 5. 3 times 4, it will give you a 7. And then you just add the 4 and 2, it will still give you a 9 and 9. See? Okay. Let's go to the next page. Okay, number 4. Okay, we still have here the same, another example here. Here, 10 plus 5, that's 15. 5 plus 8, that's 13. And then you just add the numbers 8 and 10 to each of their groups. It will give you the same answer, 23. Same with number 3 and number 4. It's just the same strategy. Okay, subtraction and division, not associative. Okay, distributive property. For the distributive property, remember, I told you the word distribute. Okay, when two numbers have been added, subtracted, and then multiplied by a factor, the result will be the same. When each number is multiplied by the factor and the products are then added or subtracted. See? You can see it here. And then you have here the examples for number 1 and 2. You just distribute the numbers. 2 and 3. You distribute 2 to 3. And then 2 and 4. It will give you an answer there. See? 2 times 7, that's 14. And then when you distribute 2 times 3, that's 6. And then 2 times 4, 8. Give you the same answer, 14. For both. Okay? Same with example number 2 and the next example. Let's check the next example. Next page. Number 5. Oh, number 5, we are now in the identity property. Remember, identity remains the same. Additive identity, when you add 0 to a number, it will give you the same number. Right? A plus 0 equals to A. 9 plus 0 is equals to 9. 1 million plus 0 is equals to 1 million. Okay, you can see the examples here. See, the identity remains the same, whether it's negative or positive. Multiplicative identity also, when you multiply 1 to a number, it will give you the same number. Right? Whether it's negative or positive, you can see here the examples. Negative 32 for number 2 times 1, still negative 32. right? Inverse property, the additive inverse and the multiplicative inverse property. See, when you add the additive inverse of a number, positive number, the additive inverse is its negative. And for a negative number, its additive inverse is its positive number, the positive of its number. So see, a plus its additive inverse negative a gives you 0. Also negative a plus its additive inverse positive a will give you 0 too. Just like with these examples here below. And also with the multiplicative inverse property, the multiplicative inverse is the reciprocal. Same with reciprocal. Okay, and then when you multiply that to the number, it will give you 1. Answer is 1. A times its multiplicative inverse is just equals to 1. A number multiplied by its multiplicative inverse is just equals to 1. Okay, next. What's more? Okay, identify the property used in each of the statements below. Okay, negative 7 plus 0 is equals to negative 7. Negative 7, the identity remains the same. So this is identity property. Okay, I will just write identity. You can just put the word property there. Identity property. Number 2, 6 multiplied with 3 and negative 5. It's distributed, right? So this is distributive. It's a little slow to write on the screen. Distributive property. Okay, number 3. Negative 8 plus negative 7 is equal to negative 7 plus negative 8. So the order of the numbers are exchange, and still the answer remains the same. So when it's the change of the order of the numbers, so it means they commute to the other side, or they swap, or they exchange places. So it's just the commutative property. Okay, and then for number 4, negative 13 times 1. So the identity of negative 13 remains the same, negative 13. So this is still identity property. Okay, you just write the word property on the other side here, beside the word identity. Now, for number 5, negative 4 times its multiplicative inverse, which is 1/4, is equals to 1. Therefore, this is what we call inverse property. Number 6, 2 times 4 times 7. Oh, the groupings. 4 times 7 is the one being grouped, but on the other side it's 2 and 4. So this is just the change of groupings, which is based on the word associate, or being in a group. So that is associative property. Okay, remember the keywords, guys, so that you can answer easily. Associative property. Now, for number 7, 11 plus its additive inverse, negative 11, it will give you a 0. So this is inverse property. Okay? And now for number 8, it's 3 times 5 is equal to 5 times 3. The order of the numbers being multiplied, it's being swapped. So this is just commutative property. Okay? From the word commute, or exchange places. Commutative. Okay, for number 9, 2/5 times its multiplicative inverse, 5/2 is equals to 1. So this is just inverse property. Okay, the multiplicative inverse of 2/5 is reciprocal, which is 5/2. Now, number 10, you can see here that 3 is being distributed to 5, and then 3 is also being distributed to 9. So this is distributive property. Alright, okay. Now, let's go to the letter B. Rewrite the following expressions using the given property. Distributive property, okay. For number 1, how do we do that? Okay, let's use the font 8. Distribute 8 times 2 plus 8 times 5. That is the distributive property. Now, number 2. Associative property, you just exchange the order. They exchange the groupings. So this is just 7 times the group of 4 and 3. Okay? Now, commutative property, exchange of order. So it's you just exchange the order. 5 plus 8. Now, identity property, the identity must remain the same. See? Negative 4 times 1 is just equals to 1 times negative 4. It will give you the same answer. 4, which is negative 4. Inverse property. Okay, you can see here 25 times negative 25 is the inverse property, which is also the same as negative 25. Negative 25 plus its inverse or additive inverse 25. It will just give you an answer 0. Okay? Very good, guys. Okay. Alright. Okay, let's go to the next page. I will erase. Oop. Next page, please. What I have learned. Okay. Let us answer this one based on the words from the boxes. Put it on the spaces. Commutative property. Number 1, commutative property states that changing the commutative, when you commute, you swap the order. Right? Changing the order of two numbers that are either being added or multiplied does not change the value. Number 2, associative property states that changing the of numbers that are either being added or multiplied does not change its value. Changing the associative. The grouping. Changing the grouping. Yes. Grouping. This one is about changing the grouping. Oh no. Changing the grouping. Oh, okay. Now, grouping. Number 3, distributive property states that when two numbers have been added, subtracted, and then multiplied by a factor, the result will be the same when each number is multiplied by the factor and the products are then added, subtracted. Number 4, additive identity property states that the sum of any number and 0 is the given number. Okay. Additive identity property. Then is the additive identity. Additive identity is 0, 0, 0. Okay. Now, number 5, multiplicative identity states that the product of any number and 1 is the given number. A times 1 is equal to A. 1 is the multiplicative identity. 1. Okay, additive inverse property states that the sum of any number and its additive inverse is 0. So additive inverse is the answer here. Oh, very small space. I'll just write the next word, the inverse word, additive inverse. Additive inverse Now, when you add its additive inverse, it becomes 0. 7. The additive inverse of a positive number is the the additive inverse is the negative of that number. Now, the additive inverse of a negative number is the positive of that number. Positive of that number. Okay. Now, multiplicative inverse property states that the product, when you multiply a number in its multiplicative inverse, like for example, a times 1 over a is equals to 1. Product means you multiply. Okay, next, the multiplicative inverse of the number a is 1 over a, the reciprocal of multiplicative inverse. Alright, okay, very good. I'm going to erase this one and move to the next page. Whoop. Okay, I think there's the last page there. Yeah, this is the last page. Here's another activity that lets you apply what you learned about the properties of operations on the set of integers. Okay, identify the properties applied in the following real-life situations. Okay, what are the properties applied? Number 1, Leo and Kurt order sausage and pepperoni on their pizza. So what do you think is the property being applied here? Leo and pepperoni added sausage and pepperoni on their pizza. So it is a new pizza, right? So a pizza plus sausage and pepperoni, it will become another type of pizza. It is, we use the closure property. Okay. Now, okay, number 2, Ricky went to the supermarket and bought ice cream for 12 pesos, bread for 8 pesos, and milk for 15 pesos. How much money do we owe the cashier? Okay, 12 pesos, 8 pesos, and 15 pesos. So, how much do we owe? Like for example, this one, you could do the 12 plus 8 and then plus 15. Okay, we can do the associative property here, like 12 and 8 first, and then, or we do 12 plus to the 8 plus 15. So we can also do the associative property here. Associative, we can apply associative property here. Next, number 3. Okay, Ross was doing his math homework while I was finishing my science reading. Okay, all you can do, you can just say, I was finishing my science reading while Ross was doing his math homework. So you can just do the order of the words. So order, that is just the commutative property. Just change the order. Now next, number 4. Grace Joy has 8 notebooks and her brother has 6. If you double both amount, how many do they have altogether? Both amount, double both amount. So 2 multiplied to 8 and 6, that is distributive property. Okay. You just write the word property, okay? This is distributive property. Next, a personal driver's license. Okay, number. Okay, if you have your personal driver's license, like my number, it starts with L 3 4 5 6. For example, this is the personal driver's license, and then when you multiplied it with 1, it still remains the same number, right? Same number, L, 3, 4, 5, 6. So the identity remains the same. Therefore, the property here is identity property being used. It must remain the same. Okay, here. During a physical exam, Noemi's doctor checked her blood pressure, blood sugar level, and then heart rate. So we can also do this one, the associative property. Okay, because there are three things being done here. Check the blood pressure, check the blood sugar, and then the heart rate. So we can also do the heart rate first, and then the blood sugar, and then do the blood pressure. So you can do the associative property here. You can relate the associative property. Now next here, number 7, Bonnie first poured a bag of cement into a bucket along with some gravel, thus added water to this mixture. Everything will work out fine. Okay, so cement added to some gravel, and then you added some water. So cement 1, and then gravel 2, and then water. Okay, so you can also do the associative property here. Associative property, when you can combine first the gravel and the water before you add the cement. Yeah, it's still the same mixture. Okay, here for the number 8, personal thumb mark is a unique identification. So that is just identity property. Okay, thumb mark multiplied with 1 is just equals to the same thumb mark. JR has 10 boxes, number 9, of canned goods, and his best friend Michelle has 5 boxes of canned goods. If we triple their donations, what is the total number of their donations? Oh, okay, you triple times 3, 10, and then you times 3, 5, 2. So that is distributive property. Distributive property. Okay, now for number 10, the set of even natural numbers is closed with respect to addition because the sum of any two of them is another even natural number, which is also a member of the set. Oh, okay, so it means he's trying to tell us that 2 and then 4 is also 6, which is also part of the set, which is a different number. Same with 4, same with let's say 4 and then 6, that will give you a 10, which is also part of the set, which is closure. Yes, closure property. This is closure property. Okay, great work, very good, great work. You did a good job in applying what you have learned today. Okay, I hope you have learned a lot today as you viewed the video. You can watch again, you review one by one so that you can answer the module, and I want you to understand everything so that when you do the test, when you do final test, midterm test, whatever test is that, or quiz, you can answer clearly, okay, and easily. Remember the keywords for the closure property, they are closed. If two numbers are closed together, they form a different number. Okay, associative, when the change of the groupings is changed, it will still give you the same answer. Commutative, when the order of the numbers being added or multiplied, it will still give you the same answer. Distributive, when you distribute a factor to the numbers within the bracket or parenthesis, it will give you the same answer. And the identity property, remember, when you add 0 to a number, it will give you the same identity number. Okay, and when you multiply 1 to a number, it will also give you the same number. That's identity property. Okay, Uh-huh. Okay, and the closure property, yes, when both numbers are closed, like you add 2 and 4, it will give you another number 6. Okay, guys, very good. I hope you like our video today. This is your Math Master.
And thank you for watching. Please like, subscribe, and press the notification bell of my YouTube channel, Math Master Vic. If you want me to upload videos with math topics that you like, just leave your comment below. Thank you and see you on my next videos. Bye!